Hello and welcome. And we continue writing DBML Parser in C++. And in the previous episode, we managed to extend tables to parse relations inline ones that are specified as settings of columns. Also managed to parse checks, like table-wide checks, like those. And I'm immediately want to check if I can have many checks or only one such a block. Let's see. Yeah, I can have many of those. All right. And also what we've done, we've added alias to tables. And this is it, because we wasted half of the episode time to just implement this fatal function that exits and prints an error. Anyways, next thing would be to implement indexes inside table, and then relationships. I mean, like those. Yeah, those one, a long form and a short form. The relationships, they are defined outside tables. It may include like multiple columns and stuff. But before all of that, I think today finally we'll start implementing some data structures. Not structures, but kind of um, types representing all of those things, all of those entities. Because for now we don't capture them anyhow, we just store them in some local variables in the functions that parse them and just print and do nothing else. So today I'm gonna fix it and define types for all of the entities we can parse at the moment. At least that's the ultimate goal. We'll see how it goes. All right, so let's then start, and we would have for each entity their own file, maybe. So I know we have Enum, and we might start from it. So let's check what we have in our, or we have project to start from. So, and the project has those three things: project name, database type, and node. So we can even copy it. And for now, I'll just write it right here, but that's for convenience. I then would move it into a separate table, because here I see everything that I need, every property. It would be struct project, and it would basically have all of these things. So, yep. And basically that's it. And I guess instead of those, I can now have just project, and then say, and here I would probably remove this, just have project name. And let's see how where is this project definition? Yeah, it's just, this is okay to just call it name. This is just an example. It's not like a property type called project name, so we can name it as we want. All right, so we say then that project dot name is this. Now here we say project database type and project node. Yes, and we would return it as well. So we'll say it returns a project. And here we would do it, return a project. Now, I don't know how to actually create a file from inside Vim, so I have this Vim cheat sheet. I hope it helps me somehow. Okay, I probably have to just Google it. Vim create file. I know because I know there is thing like this one. This is the Explorer, and maybe there is something. This quick help. So finding, listing, sorting. How do I exit it? Yes. Okay, this is the Vim Explorer. So create Explorer. Okay, cool. So it would be project. Yes. Oh, and it is even opened as a separate one. How can I then swap between them? There is something, yeah, multiple. Split, switch. Yes. Can I just now do like this? And yeah, ooh, this is cool. This is cool, but now we also have to unindent it and add some imports here. Not import, it includes. So this is string view and optional. And we better we better define this header. We say if not defined, no parser project. We define and we do this. Ooh. And at the end we do and if this thing, and yeah, like this. Yes. Okay, Okay, we now write it, and here we remove it and just include it like here, like this. Let's open this Explorer and see what we have. We have project. So we have to go into this make lists and add it here. So we say project. Go into Explorer. Let's go to parser back. So we do it. Consume project here. And now I'm thinking like where to put this all cout thing, where to put this representation of project, whether to put it into it somehow or no, I'm not sure really. Whether to make it like a two-string thing or not. I guess for now I would just then how by the way, how did I split it? Split window, Control yes. So let's go into this Explorer, and what we need, we have this project, and we might want to just move this copying into, not copying, but printing into it. So we do, now we just yank. Here we go into project, and we would add a friend method to it. So we include this stream, and we would have, I don't really remember how to do it. It's something like friend or stream operator, and we have a stream and or we don't even need friend. Yeah, we need the friend probably, and we do just this thing, but we have to change cout for this just stream. So let's change it so it is change cout for just out. Yes, good. And we have everywhere to use this project, and here for example we do this. Oh yeah, this name, and now okay, maybe it is good. Let's go here, so we can just now remove it, and instead we would do, we'll go up where we consume this project and just print it there. So we say like this, and now and just say out this project, and let's see if it even works. So we have to define alias again, is make build and build DBML Parser, and we got some issues. Maybe first of all I forgot stds everywhere, first of all, but that's just what I reminded myself about. Let's see if yeah, so node, oh yeah, here I have also to add this project node. Oh, and I forgot to return this stream for chaining. Is it good? Yeah, cool. So we now have this project type, and it is even printed here. Nice. Now what we do, just do it for all the other things. So can I do it like this? Yes. Let's go into our parser. Let's go into Enum. So what we have here, name and list of entries, and Enum entry also has name and optionally the node. Let's define it, or if we can split it, yes. And here we go, and we switch into what? Oh, we want a new file, which is enum. And here what we do also is define header, define guard. I don't remember how properly it's called. Parser enum. We just copy it now. Define now, and if yes, good. And here we would need to write this, write struct enum, and we need name, so it is name, and we have to include it as well. Include optional, and just a list of vector entries, and we would define it here as well. Also include vector and enum entry, and don't forget those. So enum entry, we have also name, and we have a node. I included optional already. Good. So looks good. Looks good. Let's then try to use it here somewhere. So this is project. This is enum. So we say enum. Oh, and we probably cannot have a name like this because it's a reserved keyword. Let's try it. Why not? So here we include enum. We have to also open. Have to also edit it here. So this is enum. The parser, or just close all of this and try to run. Yeah, so enum is a reserved keyword. Okay, we go here and I have to rename it, and I'm really not sure how to name it. Let it be like this for the moment. And here then we say yes, and now we remove this, and here we would say so we set to the last one that we added here, the node. Oh, and I have some exit here without fatal missed. So this should be fatal. And what's the error here? So if it's not a correct entry, so we say just invalid enum entry, expected word or string, and here we return this enum. And we have to also move this thing. So let's split. Now here I want to go into Enum and have also this friend or stream later. Here we do what we go here. Let's see. So this, and here we also replace out with just out. Oh, and we have yes entries entry. Okay, or probably okay, let's do like this then. You say Enum name in Enum entries. We would have a method for it here as well. I'll copy the definition and just change that we accept the Enum entry. And here we say this. But here we have not a number like first and seconds, we have name, and here we have note. Yes. So we can read this. And here just say out entry. And I probably will name it. And here we have not Enum name, but just name. Yes. And we have to include stream. Let's see now what we have. And I don't have this return in the correct place. So we return Enum. And I have some, I didn't clean up properly. Let's go into parser, into this consume Enum. And yes, I have to remove this one. Okay, now what's wrong? So November 1st. Okay. Okay, so we have to just clean up. Where is it? Yes. Consume enum. Have it. Oh, it looks good here. So maybe it is a problem. Oh, wait. I have to save it, and then we go into enum and fix something here. Yeah, this is not first but name, and here is the node. Okay. Again, something wrong. So struct enum has no member entries. And how do they name it then? Oh, I didn't even name it anyhow. Okay. Yes, and somewhere no return. I probably again forgot to return this out, and here again return this out. Cool. We probably don't have any enum here. Oh, we have. Why we don't see it then? Because we don't print it. I know. Let's go into parser. And where is it? It is here. So we do basically like boom, say enum, and yeah, cool, good, super good. All right, and now we have to deal with tables. This would be the hardest one, and I'm really not sure whether to split them, like the columns. And there's a lot of like columns, indexes, and other stuff. Whether to split it into separate files or just keep everything related to tables, like what is within the might be within the table to just keep it there. I'm not sure. For now, probably we'll keep it inside. Maybe I'll just extract columns. I don't know. Let's for now just describe the structure. So I want to open the parser. I want to go into table. Now I want to split and open a new file. We'll call it table. And again, yes. Okay, and we define the table. So struct table. What we have string view name, Now we might have alias. So this is label alias. And then a list of columns, checks, indexes, and node potentially. So now we have only columns and checks. So the vector of column list of checks and node potentially. So node. Okay. This is it. But we need also the columns now and the checks because those have separate functions. So let's see columns then first. So column. For now, we'll define it here. Struct column. We have name. We have data type. We might have data type arguments. We would say type args. Now settings, and there's a lot of them. Let's see. Here are those. Okay. Primary key. I might want to have defaults for them. And I want to separate it a bit to say this is settings. Yeah, we might have a list of checks and a list of refs. And I probably, let it be here. So this is a list of this is an inline check, or it is just an expression. So might have like this checks. And here you would have InlineRef refs. And we might yeah, move it here. Okay, and the node, yes, and the node. Potential node, this is column, and also So the check it has expression, and it might have something else. Let's see. For the settings, yeah, this is it. Refs, check, increment, default. Okay, and now for checks, yeah, it's just an expression and potentially a name. Yes, there's only one thing available, and this is a name. Okay, this and name. All right. So this looks good, but we have to also define the InlineRef. InlineRef, and it has a lot of things. Let's see. InlineRef, it has type, it has target table and target column for now. And for this ref type, I guess we would do some num class something like this. Just do for now be short, and we have 1 to 1, 1 to many, many to 1, and many to many. Here we say kind, we say why is this so? Okay, so it's table. And column. Yeah, and we would have to modify the parser to actually use this ref kind. And maybe we would have to move it out. I guess we would move out this ref kind and InlineRef into some separate file, maybe for refs, and then we would hold both where it is. As you see here, they are separated as well, outside from the table. We might want to move it here, and we might even move it right now. So let me change here, open it, and let's make a new file, call it ref. And I would get this. And here I would change it to ref. Yes. And I have to make a lot of includes here as well. So we say include, oh, actually only a string view. Only a string view. Yes. And here we then include vector, we include string view. Oh. Cool. Vector string view. Else we need optional maybe. Yes, we need optional. And now we need our ref. And we can delete all of this. And we are good. Unless this is check table. Yes. Okay. Looks good. This looks good. Now we go into parser and have to change a lot of stuff. So where it is? It is here. Consume column, consume checks. Let's get into checks. But first of all, let's include table. And go into consume checks. And we have a vector of those. But we might have them multiple times this block. So instead, what I'm thinking, like first of all, we have to actually define, create a table here. So we say table, and we say table name is this. This will remove. If we have alias, we say table alias is what we consume. And yeah, this is printing. For now, we keep it. And here we have this. So I guess for this consume checks, I would just pass the reference to the vector so it can append it. There is also in C++ something like a function to push back. You can make of a vector and just call it, pass it a value. It's used in some algorithms, but I don't remember it clearly. This is checks. Maybe it's some kind of bug inserter. Yeah. Yeah. Actually, this is what I need. Where is it? It is in iterator. Let's try to use it. Why not? This is cool. Include iterator, and here we say that we would get it. What is the back insert iterator and container. It would be vector of check. I'm wondering, like, how should I Or should I take it by probably by value? I'll call it check append check. This we remove, this we remove. Here we define check check, and we probably can already do expression, and I'll just take this. Yes. And we have optional this, but we don't need it here. Oops. Instead, what we do is we say check name, and here we say this append check and give it the check and remove this, and we should be good for now. Let's don't touch the printing. For columns, I guess we would do the same. So we would have a similar thing here. So this whole thing. Yes, I would say append column. I don't know if it's a correct name, and let's say for now let's just say add, because append is like a method of a vector. I'm not sure. So like this, and now here this is a column, so we can say column and already say name is but I don't remember if we have some guarantee that they would be executed in such order. I guess not, so I would probably don't risk it and do like this, and just here say column data type, and this we don't need because we have in the column. So if column data type args is not empty, assume comma, blah blah blah, and here we would say fatal invalid data type argument expected string, a word or a number, now without any actual parameters for format. And here we say column data type args pushback, consume this. Here are the settings. For now, let's do like this, and we would just instead say here if it's a node, we say column node. If key, we say column. Let me try to do it like this. But you know what? I remember we talked about that we would like to make everything optional so we can check if the property was specified twice and then throw an error. So I guess for now I would just turn everything back. And we would keep all of those except for those that are optional. Maybe. I mean, for sure we can drop refs and checks. So you would append them directly, but yeah, here we say column checks pushback, and here we would have this relationship type. How it's ref type, and rename it and say the ref type is it is ref kind actually. Ref kind, it is kind many to many. Here we say ref kind is if it's left, then it's one too many. If it's right, then it's ref kind is many to one, and here kind is 1 to 1. Yes. Here we can say what? We can probably even do it not like this, but say InlineRef ref, and here say ref kind. And here say ref table and ref column, and say column refs pushback, and just do ref. Yes. Yes. And we have to return it as well. Or no, in column we don't have to return because we have this back insert iterator. But we have to call it, right? We have to call it. So this is where we consume settings. And so we do add column like this. but in table we have to return it. So we do table and somewhere here we return it. Let's see, maybe we missed something. Yeah, we did a lot. Okay, so here I missed something. Yeah, include else. Yeah, I have to fix all those things, and I forgot to specify not this. So we go into parser somewhere here, and in consume checks I have to specify how to make it std back inserter, and we what do table checks, and here we do std back inserter table refs. Yes, let's see if those are gone. Now we probably just have to fix the printing. I hope we'll see a lot of errors, and this might be not related to printing, an invalid call of it. How to use it actually? How to use it? Oh, okay. Okay, so I have to do, okay, it's good that I checked it. So let's go where we use it. This is checks, add check. So maybe, no, this is not, I don't like it. Okay, for now, let's keep it to not slow down. So we would just say naming is not good, but like this. And in the column, we do the same. So we say see if it's gone. I don't know, this doesn't look good. let's then just pass this list of checks. And just call a pushback on it, and that's it. So checks, pushback, check. And here we do the same. Columns, and somewhere here we say columns pushback column. And I have to now change, where is it? Somewhere here. Or no, how I call those consume column, consume, yes, here. So I don't need this anymore. Do like this, and here, yes. Let's see. Okay, let's add it. Have a misspelling here. And why is this table? Probably I have to do table columns. Where is it? Yeah, I have to pass it. I don't know why I passed refs. I have to table columns. Now what else? What else? Something with pushbacks. Column. Const value type. Why is it const? So we have table, and we give those checks. Oh, I see. First of all, percent, and now this is not checked. This should be column. Let's see. Yeah. So all the errors with those were fixed. Now we have to fix the printing of those. So let's go into parser, split window, and here we open Let's first open ref and do let's see. This is stable and we already printed. This is not what I need. I need column. Where I print refs. Yes, this one. Why is it opening as a split? Interesting. Okay. So printing for refs is done. Now printing for everything else, for the whole table. And this would be tough.
Let's see how to do it.
For now, I won't print settings because there's a lot of work at the moment. I'll just leave them out just to check if everything works at all. Parser 3, 2, 9. Yeah. Okay. What is wrong here? Probably somewhere I forgot that I have optionals. Yes. Table 7. What else? Check name. This is table 53. Okay. And yeah, here I have to return. So we go into ref, and here I have to return. So let's do like this. Substitute this with this globally. Okay. What else? Yeah, I have to. Here we would do substitute case with the case ref kind. Yes, and now checks table 80. We have to do it for table checks. I somewhere forgot also table alias. I forgot some thing in table operator. And what line is this? 82. Oh, yeah, I forgot semicolon. And again, somewhere, what it is in ref, probably here. I don't know why, because this is kind of, I checked all the values, but whatever. So let's then say for now. I know it's incorrect, but just to see. Yeah, and we just have to add indents and add new lines. Column is good, it's good. Here we do table, that's okay. For columns, do like this. Yes, and we just have to add some new line. Let's see how we do it in Enum. Okay, just use line. Here we would just also give an end line at the end. Yeah, good. Good. The only left thing is to actually print settings of columns. Let's check if I add some parameters like what? Interesting. So we have some error here of parsing data type. Parent open, parent close. We'll have to look into it as well. Yeah. Okay, so today we managed to describe and define some types. We defined project, has name, database type, and node. We've defined enum, which has name and entries. An entry has name and node. We defined reference. This is in line one, which has the kind, target table, target column. We have table, which has columns, and each column has name, data type, some arcs, and a lot of settings. Also table checks, expression and optional name, and table, which has name, optional alias, columns, checks, and optional note. Although we don't for now print the checks. And not the checks, but we don't for now print settings of columns. Everything else we print already. And we moved all this from parser into separate classes and files. So this would be it for today. In the next episode, we would want to finalize it. So to print settings of columns, although I'm not sure how to do this thing because we need to track how many like commas do we have to print. But I guess we might do so in the current version. If we go into parser and let's search for no, I cannot do like this. Okay, or this long comment here somewhere. Yes, you see, so we used to just check if any settings, then we do this and just decrement, and while we still have anything left, we put a comma. Now what we can do is we can instead count how many did we already print, so, or just have a boolean saying like first printed or something, and if it's true then we put comma before printing anything else. Otherwise, if not, first was printed anyhow, then we don't print the comma. That's it. The problem is we cannot somehow check whether we have any settings with it. So here you see we can check by number of settings how many we have and whether we need to print them at all, print those square brackets. And we can just do and print them always, even if they are empty, or we can instead somehow check if we have any settings at all, just go through all the props we have, like if maybe it's primary or maybe it's unique or something, go through all of them and see if any of those has value, non-default value, or have any refs, any checks, so those vectors are not empty, then we see that we have to print those. Yeah. So this is it. This is what we might do the next time. And when we finish it, we might also want some document type where we have this project and all the entities like enums and tables stored, like the parent class, parent structure. And then we also need to continue implementing other stuff, indexes and relationships. I mean those out of table relationships, not like this, but like this. Yeah, so this is it for today. Today was a little bit tedious, I would say. So not so much of some engineering, just moving things around, defining types, and struggling with this stream operators. But anyways, this had to be done at some point because this was a whole mess how we printed and stored things. Yeah, this is it for today. Thanks for watching. Like, subscribe, share. You know what to do. And see you in the next one.